It's the first time I've given a talk with opening music. So it's a little bit different for me being at this a conference like this. Usually I'm speaking mostly to my colleagues. I do give some public talks on climate change, but really this is the most exciting for me, and I guess what's most gratifying to me is that there's so much action involved in this this summit, and usually talking mostly just about the climate system and about the physical aspects, and we just sort of put it out there, and we hope someone's going to respond to it. And it looks like, you know, things are finally starting to happen. We certainly have our work cut out for us, but it's immensely gratifying to me to see such a diverse group of people with diverse interests here to address really what is one of the biggest crises facing humanity. I'm pleased to start off the conference with really mostly a science talk, and I'll be talking about some things on the global scale, what's happening on the global scale, and then I will zoom down and focus on what kind of climate change has occurred and what we can expect to occur in the Northeast. And of course, what we get, as you probably know, in the future is going to depend on a lot on what we do. So a lot of it is in our hands. So let's get started. I will start with this figure here, which shows how the temperature of the Earth has changed over the last 150 years or so. And it's showing the difference between the temperature in the middle of the 20th century and the date shown. It's scrolling from the late 1800s, I believe, all the way up to the present day. So where you're seeing yellows and reds and oranges, that's where it's warmer than it was in the middle of the 20th century. And where you see blues, it's where it was cooler. And so you can see that the Earth just about everywhere has gotten warmer. And if you focus there, this is shown in units of degrees Celsius. And if you focus there on the Northeast US, where Pennsylvania is, you can see that we've warmed about 1 degree Celsius or almost 2 degrees Fahrenheit since the middle of the 20th century. So there's lots of things that are happening as well besides just warming of the surface air, which was shown in the previous diagram. The Earth is warming, and that includes the ocean. When the ocean warms, just like any liquid, it will expand. Also, and that will cause sea level to rise. Also, what's happening is that ice that is locked to the land, like glaciers and ice sheets, are melting. That water is running off into the ocean and is also causing additional sea level rise. And in fact, that second process is why we're seeing the rates of sea level rise that are so high now. They're 5 or 6 times greater than they were at the beginning of the 20th century. So sea level is not just rising, it's accelerating. And it's following a pattern that we expect as a result of increases in greenhouse gases. So those units there are millimeters. That's 200 millimeters. That's about 8 inches. We've seen about 8 inches of sea level rise globally. Regionally, we can see much more than that or much less than that, depending on a whole variety of factors, including changes in ocean currents. And in fact, what the land is doing. The land is also moving up and down in various places. So we have evidence from surface air temperature. We have evidence from the rising sea that the Earth is warming. But there's lots of other lines of evidence that also indicate that the world is warming. And you can see here the main thing, then that's the main thing that you need to know, not necessarily the details of these graphs, but the temperature in the atmosphere and the troposphere, the upper part of, a kilometer or so up in the atmosphere is going up. The heat content of the ocean is increasing. We can now measure that fairly accurately with basically robots, about 3,000 or so robots that are traversing the ocean, measuring it about every 10 days. And so we're seeing that from those data. As the planet warms, more water evaporates from the ocean. That increases the humidity in the atmosphere. So we're seeing the humidity going up. Warming leads to declines in snow cover. It leads to declines in sea ice, frozen seawater. We're seeing it decrease very rapidly, particularly during the summer in the Arctic. And as I said before, we're seeing glaciers decline in the amount in their size. So it's really incontrovertible evidence that the Earth is warming. There are many lines of evidence supporting it. And now what's causing that is probably and you've heard many times, but I do like to present one of the ways in which we know why we're seeing the warming that we're seeing. When we try to model that using fundamental laws of physics and chemistry with very sophisticated computer models, which I consider really one of humankind's great contributions. It's, for me, these models are among the wonders of the world. They're remarkable international collaborations across many, many disciplines of science, including my own, which is oceanography. It involves folks that study the atmosphere, of course, specialists in clouds, specialists in solar radiation, ecologists, geologists. They're really remarkable pieces of science and engineering. We can use these to experiment because we can't really experiment with the Earth. I mean, we are experimenting with the Earth. I should say that. We're doing an experiment right now, but it's sort of an uncontrolled experiment, and we really only have one shot at it. But with computer models, these global climate models, we can conduct multiple experiments. So we can try to see if we can reproduce the observed warming just using natural variations, natural influences, such as volcanoes, such as changes in solar output. Even the orbit of the Earth is changing a little bit, and that's having some impact on the climate. But as you can see, all of those, what we call natural drivers, have a very, very modest effect on the global average temperature, which is shown by the black line there. And globally, we've warmed about 2 degrees Fahrenheit over the past 100 years or so, much of that in the past 50 years. And we just can't recover that warming just from natural influences. When we include human drivers, such as increases in greenhouse gases due to fossil fuel burning and other things, greenhouse gases such as carbon dioxide and methane, even ozone, those all contribute to warming. There are some other human activities that actually lead the planet to cool. Fossil fuel burning also releases particles into the atmosphere that reflect sunlight back to space. Those are aerosols. Those cause some cooling. Our changes in land use also cause a little bit cooling. And when you add all those effects up together, it's a net warming that is very much in agreement with what we have observed. So what's happening is we have these greenhouse gases, and let me just explain the greenhouse effect very quickly. It's really an important process that occurs in the atmosphere, and it's actually a very good process. It's just on a bit of overdrive now. The sun, as you know, warms the planet, but the Earth radiates out invisible radiation. We call it infrared radiation, back out to space. But it turns out that the atmosphere is very opaque to this radiation, and it absorbs most of what is coming from the Earth. That causes the atmosphere to warm, and a warming atmosphere will radiate in all directions, and some of that radiation comes back to the Earth. This is good stuff. This is good radiation. It's not like stuff that'll give you cancer. This infrared radiation is warming. It's very beneficial, and it warms the Earth quite a lot, 60 degrees Fahrenheit. So we would really be living on an ice planet if it weren't for the greenhouse effect. And so what we have, and these greenhouse gases, carbon dioxide, water vapor is also a very, very important greenhouse gas, have done a good thing. We're just seeing that being accelerated by carbon dioxide being put back into the atmosphere that was drawn out of it many millions of years ago as a result of photosynthesis and burial, right? Those are our fossil fuels that we've put back into the atmosphere. So this greenhouse effect, we've known about it for quite a while. Fourier described it in the early 1800s. He realized he couldn't account for the warmth of the planet without the greenhouse effect. Then Eunice Foote and John Tyndall identified the greenhouse gases in the atmosphere. Some 50 years later, Nobel Prize winning scientist Svante Arrhenius estimated the greenhouse effect due to fossil fuel burning and actually did a pretty good job of it. And then finally, Guy Callender documented the warming and the carbon dioxide increase. So this is really old science. It's not like everything is figured out, but the basics of it we've known for quite a while. Okay, so to summarize that introductory part, many lines of evidence. This is from the National Climate Assessment. This basically comes from the US government. It's put out by our current administration in the White House. This is a report that had the blessing, as it were, of our government that says many lines of evidence demonstrate that it is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century. And there's really no alternate explanation. For the period extending over the last century, there are no convincing alternative explanations supported by the extent of observational evidence. So it's not something we really should be arguing about. Maybe you might feel like, I don't even need to tell you this, but still there are many people that do not believe these basic facts. So I feel like it's important for us to get it out there at the get-go. So let's move into some of the local impacts. And I've been part of a team at Penn State that's written 3 climate impact assessment reports for the state. It's Pennsylvania law that the impacts of climate change on the state need to be assessed every couple of years. And a group of us, led by an economist, but we have foresters, we have wetland ecologists, we have oceanographers like me, we have a whole variety of individuals that study the impacts of climate change on the state and write reports. And I'm giving you some results from that report as well as some other literature that has come out since then. Our last report was in 2015, and there's a current report being worked on as we speak. So one thing that's happening, this figure shows the trend in the leaf out date for plants, or the first bloom. So what we're seeing here is that every decade or so we have leaf out and bloom that is a few days earlier. That's what the reds show, some 4 or 5 days earlier per decade. So that's an indication of our increasing growing season length. So climate change is something we don't not only see in terms of temperature, but we're actually seeing ecosystems respond to it. That's causing bees to some of the ecological impacts, or bees are arriving earlier in the 10 days or so earlier in the Northeast than they used to. So ecosystems are responding. Here's an odd thing that's happening to our birds. You don't see this get much attention, but this is research done not very far from here at the Powder Mill Avian Research Center. is that birds are getting a little bit smaller, and this is what many animals do this when they experience warming. Their metabolism adjusts in such a way that they actually get a little smaller. And there are actually many climate impacts that are affecting birds. Birds, like many other organisms, are moving poleward and to basically be in a climate that they're more used to. And we see this sort of poleward migration in organisms throughout the whole world, on land and in the ocean. We don't really know what the effects of these ecological changes will be. It's still uncertain what the ecosystems are very delicate. They've evolved in complex ways over many millions of years, and we're basically throwing a monkey wrench into the system, and we don't know quite how they will respond. Some other impacts we're seeing as the climate warms. We're still getting snow, of course, as you probably know, but we don't get as much as we used to. And this figure shows the ratio of snow to total precipitation, the trend in that ratio. So wherever you see a red dot, that means there's less snow for the given amount of precipitation that we've had than there used to be. And the blue square means that there's more snow. And you can see that there are trends in both directions, but generally we're seeing a decline in the amount of snow. Our total precipitation is actually going up. It's mainly increasing in the fall, which may be in itself a result of climate change. But this trend that we're seeing here in having sort of wetter winters, our precipitation being more liquid, is certainly due to the climate change that's been observed. And this has ecological effects in itself. Some of my colleagues at Penn State have shown that the snowshoe hare, which is sort of at its southern limit here in Pennsylvania, is actually declining and is retreating to sort of areas that are the coldest areas of Pennsylvania and have the highest snowpack. And you can see why that would be the case from this photograph here, which shows that the snowshoe hare shows up quite well on a background without snow compared to its darker cousin there. So this is one way the snowshoe hare, by having snow around and having a white coat, it's one way it avoids predators. So we're seeing impacts there. Other changes in the climate that are happening in the U.S., happening globally, is that precipitation is heavy precipitation is increasing. Even in places where the total precipitation is going down, we're seeing the precipitation in the wettest events going up. And this shows the state of affairs in the United States, what the trends have been in the United States. We've seen very large increases in precipitation. These are the top 1% rainiest days throughout the U.S., particularly in the Northeast, where that increase has been almost a doubling. And this is something that we expect with climate warming. As I noted before, the humidity of the atmosphere is going up. That's because higher temperatures allow a greater capacity for the atmosphere to hold water. And that means when a front comes along to trigger a precipitation event, we have more moisture in there available for precipitation. I mean, I liken it, the atmosphere, it's not a perfect analogy, but it's kind of a sponge for water vapor. And by warming the planet, we've essentially made the sponge bigger. And so that when you come along and wring it out, you have a bigger precipitation event. And of course, this causes all kinds of problems with sewage overflows, for example. There was a display I was at earlier talking about so-called combined sewer overflows, where our drainage system can't handle a heavy precipitation event, and actually some sewage comes out of our pipes and into our waterways. So there's all kinds of problems that are associated with heavy precipitation. Okay, so we've looked a little bit at the past in Pennsylvania and a little bit globally, and now I want to turn towards what our future might bring. And this is where we can use the climate models as a tool for investigating what we might be in for, depending on what emissions pathway, carbon dioxide emissions pathway we choose. And here are just three illustrative pathways that have been used by the Intergovernmental Panel on Climate Change and the National Climate Assessment that I was talking about earlier. It shows in black what our fossil fuel emissions have been over the past 100 years or so, up until the present day. And then it shows three scenarios. A higher scenario that's in red, that's kind of a business as usual scenario. We sort of keep increasing emissions as they have been increasing. Then we have a very low emission scenario, similar to one that Grant Oliphant talked about, where we reduce our emissions fairly dramatically. It's not the lowest, certainly the lowest they could go. And then there's an intermediate emissions scenario there as well. So these end up having very different climate futures, and this figure is similar, but now it's showing the temperature change that we've observed and also modeled. And as I told you earlier, those are in very good agreement. And then they look into the future to see what the temperature might be. And the shading gives you some sense of the uncertainty because we do know a lot about the climate system, but there are still numerous uncertainties in climate science that are important and need to be resolved. And so you see a range of possible global future temperature changes. And so in the higher scenario, and that's also not the highest, but in the higher scenario, the warming globally is something by the end of the century between about 5 and almost 10 degrees Fahrenheit. Whereas the very low scenario is more like a warming of between maybe a half a degree and 2 degrees, or 2 or 3 degrees. So it's quite a difference. Emissions really do matter, and they really start to diverge towards the second half of the century. And to give you a feeling for, when you say, well, it's a few degrees, is that really something we need to worry about? And when you look at the difference between the climate we have now, or the pre-industrial climate, let's say 100 years ago, and what we had from the last ice age, we're talking about 4 or 5 degrees centigrade. So, that's a vastly different climate, right? But yet it's just a few degrees. So what seems like a small amount of temperature change can lead to very dramatic changes in the climate system. Okay, so getting back to Pennsylvania now, what can we expect in Pennsylvania? We've seen Pennsylvania warm. That's what this figure shows. That's what the ziggity line shows there, and it does emphasize that there are natural variations in climate as well. Some people think it's one or the other. They say, oh, climate always varies, but that doesn't mean that humans can't cause climate change. Both are happening. We have natural variability, and superimposed on top of that, we have a long-term warming due to increases in carbon dioxide and other greenhouse gases in the atmosphere. And then you can see the projection into the future. And again, there's quite a difference between a lower emissions scenario and a higher emissions scenario. And we're seeing, it's alarming. By the end of the century, there's a range of temperature change between, say, 6 and 15 degrees Fahrenheit, right? That's quite a lot, and larger than the global average. And the reason is because land generally warms up faster than the ocean. So land areas will experience a greater warming than the global average. And that's also what we have observed when we looked at that map earlier. I should have pointed that out of how temperatures changed over the Earth. The greatest areas of warming are over land, and also in high latitudes where we have some interactions with melting ice. So what does that mean, this warming? What does it mean for Pennsylvania? This is something we created for the climate impact assessment we did with the state. This is what we call a moving cities analog, and it says what our climate will feel like by mid-century for different cities by moving them to the south. So if we do the case of Pittsburgh, since we're here in Pittsburgh, if we keep sort of our business as usual emissions scenario by mid-century, which is only like 30 years away now, our climate looks like that of Knoxville, Tennessee. And our summers would feel like those in Knoxville, Tennessee. And Philadelphia, for example, will experience summers that are like those of Orlando, Florida, right? So these are big changes. We're talking about changing the character of where we live, right? The character of a place is one of the most important characteristics of a place is its climate and its weather. It's almost when you go and you meet someone new and you talk to them about where they live, one of the first things you often talk about is what the weather is like there and how it compares to where you live, right? It's a defining characteristic. So we're really talking about very fundamental changes in the way we live, really. Okay, and this is actually an old figure. It's 10 years old, but the science really hasn't changed that much in 10 years. And I think I was here 5 years ago giving a talk to the Allegheny County Public Health Department. It was a conference that they sponsored, and I believe I showed this graph, and it just shows the days over 90 degrees. And you can see historically in Pittsburgh, we've had maybe on average 5 or 10 days in which the high temperature gets above 90 degrees. And then we can use our climate models and make projections into the future. Turns out for the short term, it really doesn't matter which emissions pathway you go on, and this has to do with the long lifetime of CO2 in the climate system and the large thermal inertia, the inertia of the climate system. It responds slowly. The emissions pathway really doesn't matter on the short term, but you really start to see the two scenarios depicted here diverge to the point where under a higher emissions scenario, almost more than 2/3 of the summer are days above 90. Whereas if you go on a lower emissions, and this isn't the lowest, but in this case it's just a different one, you see about half as much days over 90 degrees. So that's going to have a big impact on public health, right? We know that people die when under extreme heat, particularly in urban areas where you have an urban heat island effect sort of exacerbating the long-term warming. And, that brings out a larger point about climate change. It's what we call a threat multiplier. I think it's a military term. I mean, many of the things that happen with climate change have always happened, but they're happening with a much greater frequency than they used to. And that goes for the forest fires that are occurring out in California now. We can't say that particular fire was caused by climate change, but what we can say is that climate change has made it a lot more likely. And studies show, for example, that there's been about twice as much burning of our forests in the West as a result of climate change. So we'll see this time and time again. Our storms, for example, our severe storms like hurricanes, those are getting a little bit stronger, but more importantly, they're happening in an environment that is a lot moister. And so they dump a lot more precipitation. So studies have been done with Harvey, that huge storm that hit Houston not too long ago, and several other tropical cyclones. And we now know that those storms, we can't say, yeah, climate change caused that, but what we can say is that climate change made it worse. It caused 5 or 10%, maybe 15% more precipitation to occur. So we were really asking the wrong question for quite a while. Did climate change cause X, Y, or Z? And the right question is, how much worse has climate change made X, Y, or Z, or how much more likely has it made it? And it's taken us a while to come around to that, and the science is really evolving. The so-called attribution science is really evolving very quickly. Okay, so other things we can expect from our climate models is that summers may be a little bit drier. This is showing the percent change in precipitation, so the browns are a drop in precipitation. This is for the middle of the century, and there's a lot of consensus among the models that the winters and springs will become wetter and a good deal wetter. This is showing, for example, in Pennsylvania, 10 or 15% wetter by mid-century, and this is again under a kind of a business as usual scenario. And the sort of trend of heavy downpours, the increase in heavy downpours, these are number of days where the precipitation is greater than an inch. We're seeing increases throughout the Northeast as high as 20 or 30%, and maybe in Pennsylvania, order of 10 or 15% or so. And changes will be expected in the wintertime, and probably with very negative impacts to winter tourism, or at least the traditional winter tourism, which is centered around snow, right? This is another defining characteristic of our state, is our very seasonal climate, and sometimes we don't like shoveling snow, we grumble about it, but certainly don't want to see it go away. You know, it's one of the things I really love about Pennsylvania and the Northeast. What we're seeing here is a study showing the change in the downhill skiing season length by the end of the 20th century under a low emissions and a high emissions pathway. And in both pathways, we see reductions in the, very significant reductions in the ski season length, sometimes, 100% really, just it's completely gone. But there are substantial differences between these two scenarios. So what we do really does make a difference. Other impacts that we have seen and that we can expect to see, ecological impacts, are about, this one example here is our state tree, which is the eastern hemlock. If you've been out hiking, you will undoubtedly come across a stand of hemlock trees that is like a ghost forest, right? Very seriously has lost a lot of its vegetation, and that's because of this pest called the woody adelgid. Now, this pest would be there without climate change, so I'm not saying that climate change caused the woody adelgid, but our warmer winters allow the woody adelgid to basically more successfully overwinter, so that when the leaf out begins, they're really ready to attack the tree. So our warming winters has certainly exacerbated the problem of this pest. And this map shows in gray and red is where the hemlock is safe today, right? So that includes where we are right now, much of where we are or near where we are in southwestern Pennsylvania, extending to the north and the west of us. But then with this higher emission scenario, the hemlock is only safe where the red area is. All this gray area is kind of a not suitable habitat for the hemlock. So this is, this really very profound effect on our ecosystems, which we rely on, not just for recreation, but it's they sustain us, right? They give us clean water, for example, by filtering pollution out of water. So they're immensely important, and climate change is exacerbating an already challenging problem. Another issue, this is a very complicated one, but it's pretty clear that the tick, a black-legged tick or the deer tick, right, which is the main transmitter or vector for Lyme disease. That's really expanded in its range. We know that, and that's very likely due to, it's probably due to the same thing about overwintering, right? The tick can do a better job because it's experiencing fewer hard freezes. So the range has expanded, and what this study is showing, this is a study in Millbrook, New York, which monitored ticks on squirrels and chipmunks. These are interesting things for an oceanographer to read about, but I enjoy learning about these things, and they are in our report. What they found is that the larval peak, when the ticks peak, is happening earlier. And that's what this graph shows. On the horizontal axis, it basically shows warming. That's called cumulative degree days. It's basically a measure of how much the temperature has been above freezing. And so as that increases, we're seeing an earlier larval peak. Now, what impact that will have on disease transmission is not really known. So this is a very active area of research, but this is probably useful information, even this for public health, and something you should be aware of if you go out hiking. You'll be seeing these ticks earlier in the season, basically, more in the spring than you used to. Okay, so there's a lot of bad news there, I admit, and we definitely have a huge challenge ahead of us. I don't want to understate that. But I am given some optimism by looking back at some of the challenges we've faced before. And I'll just focus on the environmental challenges. There have been other challenges, geopolitical ones like World War II, and social challenges like civil rights. And I'll just focus on the environmental ones here. We really have, in many ways, been successful at addressing challenges, and I think we often forget about those because we do emphasize bad news, and maybe that's from an evolutionary viewpoint, right? We don't benefit so much from an evolutionary standpoint from good news, but we do want to know if there's a predator or something behind a tree that might be attacking us, right, for our survival. So the news cycle, always is emphasizing bad things, but it's important for us to look back and to see what problems we have solved. So I'll just go through that a little bit as I get to my concluding remarks. And I think locally we have a lot of inspiration, right? Donora, Pennsylvania. I haven't been to the Smog Museum, but it's one of those bucket lists. I'm probably the only one who has a Smog Museum on my bucket list, but I'm going to get there. And I was tempted to try to fit it in on this trip, but I just couldn't. But this was a really serious smog episode, one of the first that at least got a lot of attention in 1948, and there were zinc mills there in Donora that were just spewing all kinds of nasty stuff, and you combine that with a temperature inversion in the atmosphere, which leads to a kind of a trapping of the pollution, and a lot of people died, right? 20 people died from a pollution event, and this was one of those events that really triggered, kind of an environmental movement to get improve the quality of our air, and eventually we got the clean air. We got the EPA initiated, right, by a Republican administration. We got the Clean Air Act and its amendments, very important amendments, also passed by a Republican administration. So, this is Philadelphia, but this is a smog episode in Philadelphia. We just don't see this as much as we used to. It's not to say that all our air quality problems are solved, but they're certainly less frequent than they used to be, and the data really bears that out. Ozone levels have declined. This is the bad ozone, which is kind of the ozone that we breathe, the lower part of the atmosphere. That's declined a lot. Our nitrogen oxides, which lead to all kinds of problems, have declined. Carbon monoxide has declined, sulfur, and so forth. Lead, this is nasty stuff, right? And so we've really cleaned up our act, and we should be proud of that. We had good science, we had good policy, and and we really benefited from it. This wasn't just like a tree hugger thing to do, right? Our emissions went down, and we ended up saving a lot of money because people were not going to the hospital as much. They were working. So when you add it all up, it turns out to be a huge economic benefit. So if you're just a bean counter, you want to do these sorts of things. So when the cost of our electricity barely changed, right? It even went down. So this is really a win-win situation, and something we should be proud of. And there's another example now. So that was a kind of a local, national issue, air quality, which is really you're kind of regulated because pollutants such as those don't travel terribly far. If you clean up your act locally, you can really make a difference. Something like climate change, and this example here, which is the ozone hole, this is really an international problem because it doesn't matter. In this case, the ozone hole was opening up because of chlorofluorocarbons being dumped in the atmosphere. And they lived so long in the atmosphere that it didn't matter if it was coming from Australia or if it was coming from China or Europe or South America, right? So we had to get together and work out a protocol, and the U.S. was a real leader in this, the Montreal Protocol, which led to dramatic reductions in chlorofluorocarbons and is leading to the recovery of the ozone hole that you're seeing right here in this diagram. It's still got a ways to go, but it's a long haul, but it's all going in the right direction, and it's doing that because of the chlorofluorocarbon emissions reductions. So I'll leave you with these take-home messages. Pennsylvania has basically followed the global warming trend, and both of those trends, locally and globally, we know are due to increases in carbon dioxide that are caused by fossil fuel burning. This isn't a problem that's out in the future. We're already seeing the impacts, right? This is something that's happening now. And I just gave you a few examples of some of the impacts, mostly ecological, because those are kind of my interests, but there are multiple ways in which these impacts are being felt. And we're going to continue to feel those impacts. So it's something that we're getting used to. We have to get used to. We're not going to be able to I don't think, be able to turn the clock back completely, but we do. So I think we do have adaptation that needs to be, is already underway, and I think Pittsburgh is part of that, and we need to continue that adaptation. However, so that's kind of what I would call managing the unavoidable. And then this fourth point here is avoiding the unmanageable, right? We don't want a state of Pennsylvania that has no snow in it, for example, right? Or we don't want these storms that are dumping massive amounts of precipitation on us and flooding our coastal waters and destroying our coral reefs. I mean, I've said very little about some of the global climate change impacts that we normally talk about, but this is something I'm really terrified about is the fate of our coral reefs, right? They're really being fried. These are ecosystems that have been around for 100 million years, 200 million years, and we're coming along in a generation or two and wiping them out. That just can't stand as far as I'm concerned, and we need to act on that. And so that's avoiding the unmanageable, and we'll have similar things that happen here. So of course that means CO2 emissions reductions, that maybe means some technological fixes such as removing CO2 from the atmosphere. There's a lot of work to be done there, but there are solutions. We know there are solutions. Renewable energy is very cheap now, so this is something we should be implementing on a massive scale. And then the climate Right, okay, so that's the fourth point. And then this is the last point I made, is one I left with you, is that I think it's useful for us to look back and to see some of the really fine things we've done, and I've just given you a couple of examples that should empower us to do the right thing with regard to the climate crisis. Thanks very much for your time. I really appreciate it.